today's lecture. So in today's lecture, we'll be focusing on the hydration of a cement and what are the products after the hydration has happened. In previous lecture, we discussed about the bogies compounds, which are the unhydrated compounds which found in the cement. Once the hydration happens, that means you are adding the water to the cement. And once we add the water to the cement, what is happening in the cement is now there are bogies compounds, there are 4 bogies compounds. I'm adding the water and this is leading to hydration. Now, when you say hydration, it has to be very clear how does the hydration happen. Now, you will have small cement particles which are very small in size. They cannot be less than finer than 45 microns and not greater than 75 microns, which I told you yesterday that was the upper limit, 75 microns. So, but they have to be less than 45 microns, not less than 45 microns. So the minimum size of the cement particle is 45 microns. Anything lesser than that, you cannot classify that to be a proper cement particle. Now I'll come to this, to the fineness of the cement when we come to that. Right now, discussing about the hydration. Now when there are cement particles, they are round size, small grain-like particles. And when water is added to this, there is a water that's going into these cement particles. So when the water is added to these cement particles, what happens is there are 2 forms of interaction between cement and between water. One, the outer layer of this cement particle is actually hydrophobic to the water. It's hydrophobic, so it does not interact with the water. So initially you will observe, अगर आप एक bucket में cement लोगे and then pour some amount, sprinkle some amount of water on it, you will see that the water particles will remain separate and the cement particles will remain separate. But then there is a layer of the cement particle which slowly begins to absorb. Initially it's hydrophobic, then it begins to absorb the water and interact with the outer layer of the cement particle. Even after 24 hours, even after 24 hours, you will have just around say 4 microns outer layer of cement particle that has actually interacted with water. So if this, let me enlarge this, if this is a cement particle, even after 24 hours, you will have only this much amount of the water entering into the cement particle, only into this much layer. So after 28 days, it still is near some 10 to 12 microns. So most of the cement remains unhydrated. So this cement inside is actually unhydrated cement. It does not undergo hydration. So in this outer layer, after 24 hours, you will have 4 microns. After 28 days, some 10 to 12 microns of the depth of the cement particle is ingressed by the water, and that is only reacting with the water. So that layer which is reacting with the water, which is undergoing hydration, that forms the hydration products. Now there are 4, इसमें 4 bogies compounds है. So in the outer layer, they will interact with water. The first one was C3S. Now, when you say C3S reacting with water, or you have C2S reacting with water, the final products that you will get is the hydrated calcium silicates. From these two, you will get the hydrated calcium silicates. Now, these hydrated calcium silicates, what is their shape and size? First of all, their composition. So you have 2C3S plus 6H. This is the chemical reaction of this. It's leading to C3S2H3 plus 3CaH2. So this is the chemical reaction. So this is the hydrated calcium silicate that's formed, this one. This is the hydrated calcium silicate. And apart from that, there is one more product formed, which is calcium hydroxide. And calcium hydroxide within the cement, calcium hydroxide is what? Lime. So this C3S2H3 is in the form of a gel, and that has got a crystalline nature predominantly, which I told you yesterday. So it's a gel which has got a crystalline nature. What? C3S2H3. I'm talking about this, the calcium silicate, hydrated calcium silicate. It comes in the formation of a gel-like. So what it eventually forms in a cement, if you are adding the water, so if this was cement first, then we added water to it, what will happen is that the cement as a whole will transform into some kind of a gel. It will transform into a gel, but still then within that gel, there will be small particle sizes that have not interacted well with the cement yet, small sizes, and they are the unhydrated part of the cement. So there is always a hydrated part of a cement and there is an unhydrated part of a cement. Now, the difference between this, what I told you initially, this is one cement particle. एक cement particle में भी पानी जो है that the water ingress जो होता है वो कुछ microns तक ही अंदर जा सकता है and chemical reaction is actually happening in the overall outer sphere of the particle. लेकिन जब हम पूरा एक बंडल लेते हैं, बहुत सारे सीमेंट पार्टिकल्स है, तो सारे सीमेंट पार्टिकल्स तक पानी नहीं पहुंच पाता है. जब पानी नहीं पहुंच पाता है सारे सीमेंट पार्टिकल्स तक, तो कुछ पार्टिकल्स ऐसे रह जाते हैं which remain in an unhydrated formation. So there is an hydrated cement, then there is an unhydrated cement. So even after years and years, you will have unhydrated cement, the cement that has not reacted with water. You will have that cement still present within the. Now that will be a small percentage, 10% after 1 year. It goes on decreasing with year and year, but even after 30 years, you will find an unhydrated cement within the overall cement structure. So this is the calcium silicate hydrate. Now, this is also known as CSH gel. This is also known as CSH gel. C is calcium, S is silica, and then it's hydrated H. So it's also known as CSH gel. It's also known as tobermorite gel. Another name for it is tobermorite. It is now this gel is crystalline, but it appears amorphous. So this is formed from C3S, the combination of C3S with water. Now, you can get the CSH gel also from C2S. So the reactions may be different, but at the end, the formation happens of C3S2H3 again from C2S once the water is added to it. Then there is a difference between what is the difference between C3S and C2S? That is in the nature of the reactions. To that I will come later on. Calcium silicates जो होते हैं ये they exist in variety of forms या crystalline forms. They can be fibrous crystalline form, rectangular form. So it's actually a network, a crystalline network, a rectangular crystalline network. Then there is an irregular form which has got no formation. Irregular is just a random formation of the crystalline gel. Fibrous is fibers always come like strands or brands like this. So and the reticular is always like it's a closed envelope. So this is the, if you look under an electron microscope of the nature of the particles after they have combined with water, once the hydration has happened, you will get this form of. Now there is some a third one is that is before coming to that, I wanted to discuss about this. What happens during this reaction when it's combining with H from H2O? It's combining with H from H2O. You have something like, this is an exothermic reaction. So you always get heat of hydration. You're getting heat of hydration from this reaction. Now, what is heat of hydration? It is the heat that is generated from this process, this chemical reaction. Now, that can be heat of hydration generated is quite large here, so you can measure that. So for that, we can use instruments to check what is the heat inside concrete. तो जब हम सीमेंट को पानी के साथ मिलाते हैं, so what we can do, we have instruments to measure the temperature of the inside of the concrete or of the cement. So you will check the heat and the temperature rise within the cement, so you can know how much amount of actual reactions are happening within the cement. So if you want to do a proper check whether your cement reactions are good, अगर आपको ये check करना है तो आप वो इंस्ट्रूमेंट्स लोगे जिनमें वो टेम्परेचर मेजरिंग इंस्ट्रूमेंट्स हैं जो आपको सिंपल एक हीट जनरेशन देगी कि कितनी हीट जनरेशन अंदर हो रही है विद इन द सीमेंट बॉडी. So it's giving you the whether the reactions are actually happening or not. If heat is not generated, then the reactions are not happening. So your concrete will be very poor. If the reactions are happening, if the heat is generated, you are measuring that from the temperature, so the reactions are happening in that case. That means your concrete or the cement final product will be strong enough. So, but now there are certain you can get the standards that the physical tests have already been performed. तो कितना पानी ऐड करने पे कितनी रिएक्शन होती है और कितनी हीट जनरेट होती है, you can form by Lee Catelier. He performed this experiment to note down the heat of hydration somewhere in 19th century. Some 150, 130 years ago, he performed this experiment to note down whether the reactions are happening or not within the cement. So this is one way of noting down whether your cement has reacted or not, whether it has hydrated or not. There could be more methods of determining whether the hydration is complete or not, but they are then strength-based methods and other methods which will give you the actual change after 28 days, after 7 days. But You can also check the mass. What is the change in the mass? Heating of the cement. If the temperature of the cement is taken higher, above 60 to 70 degrees Celsius से ऊपर, and at 330 degrees Celsius, it has totally disintegrated. So at 330 degrees Celsius, due to the presence of this calcium hydroxide in the cement breaks apart. It completely disintegrates. So heating above 330 degrees Celsius, not 330, it's 430 degrees Celsius, is not advisable in cement. But if there is a fire happening at a particular place, temperatures easily cross 430 degrees Celsius. So cement will break apart, will crack due to the presence of this calcium hydroxide. Now, coming to these heat of hydration. If you draw a graph between the heat that is generated, the heat of hydration, that the heat that's generated, and with respect to time in hours, we'll get a graph something like this. This would be somewhere near 40 minutes, 40 hours. This would be somewhere near 10 hours. So initially, a lot of heat is generated just within first 5 minutes. This is first 5 minutes. A lot of heat is generated. And this is due to the reaction of the third compound, which I did not discuss yet. One was C3S, other was C2S. What was the third one? Anyone? It was
C3A.
C3A, tricalcium aluminates. So that reacts with water. That's reacting with water, and that is producing calcium aluminate hydrates. Calcium, just the term calcium aluminate hydrate, it's producing that. So once you have calcium aluminate hydrate produced, now this again is a crystalline structure. But C3A has got a property that it reacts very fast with water. So it may lead to flash set. Now what is set? It is the setting of, set is setting of cement. We usually confuse setting of cement with it attains somewhat amount of plasticity. It's attaining somewhat amount of plasticity. Initially, it was just a fine grain. Then, जब आपने पानी मिलाया, it became just a liquid first. Then it starts to gain some amount of plasticity. So if you now rub it, it will stick to a surface, and that's when the setting is initially started. So this is known as initial setting of cement. This is known as initial setting of cement. So usually we take 10 minutes is the initial set time of cement. Usually take the first 10 minutes are the initial set time of cement. So the cement sets within those first 10 minutes, but that's initial setting. So if you drop, there is a test for that, the standard consistency and the setting time test. If you can go for that test, check of that test. That test drops a needle, and that needle penetrates through the cement within those first 10 minutes. After 10 minutes, that needle will penetrate lesser and lesser into the cement. So after 10 hours, get a final set time of cement. उसके बाद 10 घंटे के बाद अगर आप उसके ऊपर, then there is another which actually makes a mark, not a needle. It's an instrument which makes a mark. It has got a round weight at the, if it's dropped from a particular height onto the cement, it does not make a mark after 10 hours. So till 10 hours, you will see that there could be a mark formed on the cement. Just to explain this to you realistically, अगर मैं आपको explain करूँ ऐसे, within 10 minutes, if you walk on cement की slab आपने cast कर दी है और you're walking on that slab, your feet will go into the cement. Isn't it? And after some amount of time, after 10 minutes, after 1 hour, if you walk, there will be an impression formed on the cement, your walking impression on the concrete slab you must have seen at your own places. After 10 hours, even if you walk onto that with quite heavy weight, it will not keep a mark onto the surface. So that's the final setting. So this happens near 10 hours. So within first 5 minutes, the flash setting is happening. That's happening due to C3S. But then after around 4 hours here, some 4 to 10 hours, within which the final setting is actually completed, then there is a peak happening again. So this was a first peak here. This was first peak, wherein a lot of heat is generated. The reactions are happening very quick. C3A is reacting. Here at 4 to 10 hours, between 4 to 10 hours, then there is a reaction of other compounds, C3S, C2S. They are reacting within the cement with H2O, and the hydrated products are being formed. So the peak is not happening due to C3S. The peak is actually happening due to increase in the temperature due to heat of hydration within the cement itself. That's not released into the atmosphere. So due to that, and then there are certain alkalis which I mentioned yesterday. Which ones? Na2O and K2O. They also react with water and they also lead to the heat of hydration. So this second peak is happening due to that. This is the largest peak. This is the